Top 20 Electronics Interview Questions and Answers. Electronics is one of the most important fields in modern technology, covering devices, circuits, communication systems, automation, and embedded systems. During an electronics interview, employers usually test your technical knowledge, problem-solving skills, and understanding of electrical and electronic components. Whether you are applying for a role as an electronics technician, electronics engineer, maintenance engineer, or fresher in the electronics industry, preparing common interview questions can improve your confidence and performance. The following top 20 electronics interview questions and answers will help you understand important concepts like semiconductors, diodes, transistors, circuits, and troubleshooting techniques in a simple and professional way. 1. What is electronics? Electronics is the branch of science and engineering that deals with the flow of electrons through semiconductor devices, circuits, and electrical systems. It involves designing, testing, and maintaining electronic equipment such as televisions, computers, communication systems, and industrial machines. Electronics mainly uses components like resistors, capacitors, diodes, transistors, and integrated circuits to control electrical signals. Modern electronics is widely used in automation, medical devices, robotics, telecommunications, and consumer products. Understanding electronics helps engineers improve system performance, reduce power consumption, and develop advanced technologies that make everyday life easier and more efficient. 2. What is the difference between AC and DC current? AC, or alternating current, changes its direction periodically, while DC, or direct current, flows only in one direction. AC power is commonly used in homes and industries because it can travel long distances efficiently. DC power is mainly used in batteries, electronic circuits, and portable devices. In AC systems, voltage continuously changes polarity, whereas DC maintains constant polarity. Electronics devices often convert AC into DC using rectifiers and power supplies. Both types of current are important in electronics, and engineers must understand their characteristics to design safe and efficient electrical and electronic systems. 3. What is a semiconductor? A semiconductor is a material whose electrical conductivity lies between a conductor and an insulator. Silicon and germanium are common semiconductor materials used in electronic devices. Semiconductors are important because their conductivity can be controlled by adding impurities through a process called doping. This property allows them to function as diodes, transistors, and integrated circuits. Semiconductors are the foundation of modern electronics, including computers, mobile phones, and communication systems. They help control current flow, amplify signals, and perform switching operations in electronic circuits efficiently and reliably. 4. What is a diode? A diode is a semiconductor device that allows electric current to flow in only one direction while blocking current in the opposite direction. It has two terminals called anode and cathode. Diodes are commonly used for rectification, signal detection, voltage regulation, and circuit protection. One major application is converting AC current into DC current in power supplies. There are different types of diodes, including Zener diodes, LED diodes, and photodiodes. Understanding diode operation is important in electronics because diodes protect circuits and help maintain stable electrical performance in many electronic devices. 5. What is a transistor? A transistor is a semiconductor device used for switching and amplification in electronic circuits. It has three terminals called emitter, base, and collector. Transistors are essential components in amplifiers, digital circuits, and communication systems. They can control a large current using a small input signal, making them highly useful in electronics. There are two common types of transistors: bipolar junction transistors, BJT, and field effect transistors, FET. Modern electronic systems use millions of transistors inside integrated circuits and microprocessors. Transistors play a major role in computers, mobile phones, and industrial automation systems. 6. What is Ohm's law? Ohm's law states that the current flowing through a conductor is directly proportional to the voltage and inversely proportional to the resistance, provided temperature remains constant. The formula is V equals I times R, where V is voltage, I is current, and R is resistance. Ohm's law is one of the most important principles in electronics and electrical engineering. It helps engineers calculate voltage, current and resistance in circuits. This law is widely used during circuit design, troubleshooting, and testing. Understanding Ohm's law is essential for analyzing both simple and complex electronic systems. 7. What is resistance? Resistance is the property of a material that opposes the flow of electric current. It is measured in ohms using the symbol omega. Resistors are electronic components specifically designed to provide resistance in circuits. Resistance helps control current flow, divide voltage, and protect sensitive electronic components from excessive current. The resistance value depends on the material, length, area, and temperature of the conductor. In electronics, proper resistance selection is important for maintaining circuit stability and performance. Without resistance, electronic devices could overheat or become damaged due to uncontrolled current flow. 8. What is a capacitor? A capacitor is an electronic component that stores electrical energy in the form of an electric field. It consists of two conductive plates separated by an insulating material called a dielectric. Capacitors are used for filtering, energy storage, timing circuits, and voltage stabilization. They can charge and discharge quickly, making them useful in power supplies and electronic communication systems. Capacitors are measured in farads. Different types include ceramic, electrolytic, and tantalum capacitors. In electronics, capacitors help smooth voltage fluctuations and improve overall circuit efficiency and reliability in both analog and digital systems. 9. What is an inductor? An inductor is an electronic component that stores energy in the form of a magnetic field when current flows through it. It is usually made by winding wire into a coil shape. Inductors resist sudden changes in current and are commonly used in filters, transformers, and power supplies. Their value is measured in henries. Inductors play an important role in communication circuits, switching regulators, and electromagnetic devices. They are often used together with capacitors to create tuning circuits. Understanding inductors is important for designing efficient electronic and electrical systems with stable performance. 10. What is a rectifier? A rectifier is an electronic circuit or device that converts alternating current, AC, into direct current, DC. Rectifiers mainly use diodes to allow current flow in one direction only. Common types include half-wave rectifiers and full-wave rectifiers. Rectifiers are widely used in power supplies for televisions, computers, chargers, and industrial equipment. After rectification, filters and regulators are often used to produce smooth DC voltage. Rectifiers are important because most electronic devices operate on DC power. Efficient rectification improves power quality, device reliability, and overall electronic system performance. 11. What is an integrated circuit, IC? An integrated circuit, commonly called an IC or chip, is a small electronic device that contains many components such as transistors, resistors, and capacitors on a single semiconductor material. ICs perform various functions like amplification, processing, memory storage, and signal control. They are widely used in computers, mobile phones, medical devices, and industrial systems. Integrated circuits reduce circuit size, improve reliability, and lower manufacturing costs. There are analog, digital, and mixed-signal ICs available for different applications. Modern electronics heavily depends on IC technology for compact and high-performance electronic devices. 12. What is a transformer? A transformer is an electrical device used to increase or decrease AC voltage through electromagnetic induction. It consists of primary and secondary windings wrapped around a magnetic core. Transformers are commonly used in power distribution systems, chargers, and electronic circuits. Step-up transformers increase voltage, while step-down transformers reduce voltage. Transformers only work with alternating current because changing magnetic fields are required for operation. They provide electrical isolation and improve power transmission efficiency. In electronics, transformers are important for voltage conversion, signal coupling, and safe operation of electronic equipment and electrical systems. 13. What is PCB? PCB stands for Printed Circuit Board. It is a board used to mechanically support and electrically connect electronic components using conductive tracks and copper pathways. PCBs are widely used in computers, mobile phones, televisions, and industrial control systems. They improve circuit organization, reduce wiring complexity, and increase reliability. PCBs can be single-layer, double-layer, or multi-layer depending on the design requirements. Electronic components are mounted and soldered onto the PCB to create complete electronic systems. PCB design is an important skill in electronics engineering because it directly affects circuit performance and durability. 14. What is soldering? Soldering is the process of joining electronic components using a filler metal called solder. The solder melts at low temperature and creates a strong electrical and mechanical connection between components and the circuit board. Soldering is essential in electronics manufacturing, repair, and maintenance work. Proper soldering techniques ensure reliable circuit operation and prevent loose connections. Common soldering tools include soldering irons, flux, and desoldering pumps. Good solder joints should appear smooth and shiny. Poor soldering can cause circuit failure, overheating, and signal problems. Electronics technicians must practice safe and accurate soldering techniques. 15. What is a relay? A relay is an electrically operated switch used to control circuits using a low-power signal. It consists of an electromagnet, contacts, and a switching mechanism. When current flows through the coil, the magnetic field moves the contacts and opens or closes the circuit. Relays are widely used in automation systems, motor control, protection systems, and industrial electronics. They provide electrical isolation between control and load circuits. Different types include electromagnetic relays, solid-state relays, and thermal relays. Relays help improve safety and allow automatic operation of electrical and electronic equipment. 16. What is a fuse? A fuse is a safety device used to protect electrical and electronic circuits from excessive current. It contains a thin metal wire that melts when current exceeds the safe limit, thereby disconnecting the circuit. Fuses prevent overheating, equipment damage, and fire hazards. They are commonly used in household appliances, automobiles, power supplies, and industrial systems. Different types of fuses include glass fuses, cartridge fuses, and resettable fuses. Selecting the correct fuse rating is important for proper circuit protection. Fuses are simple but essential components in maintaining safe electronic and electrical operations. 17. What is an oscilloscope? An oscilloscope is an electronic testing instrument used to display and analyze electrical signals in waveform form. It helps engineers measure voltage, frequency, timing, and signal distortion. Oscilloscopes are widely used in troubleshooting, circuit testing, and electronic research. They allow users to observe how signals change over time. Modern digital oscilloscopes can store waveforms and perform advanced measurements automatically. Understanding how to use an oscilloscope is important for electronics technicians and engineers because it helps identify faults and improve circuit performance. It is one of the most valuable tools in electronics laboratories. 18. What is grounding in electronics? Grounding is the process of connecting an electrical system to the earth or a common reference point. It provides safety by preventing electric shock and protecting equipment from voltage surges. In electronic circuits, grounding also helps reduce noise and stabilize voltage levels. Proper grounding improves circuit performance and minimizes interference in communication systems. There are different types of grounding, including chassis grounding and signal grounding. Poor grounding can lead to equipment malfunction and safety hazards. Electronics engineers carefully design grounding systems to ensure reliable and safe operation of electronic and electrical equipment. 19. What is troubleshooting in electronics? Troubleshooting is the process of identifying, analyzing, and repairing faults in electronic systems and devices. Electronics technicians use tools like multimeters, oscilloscopes, and circuit diagrams to detect problems. Common issues include damaged components, loose connections, overheating, and short circuits. Effective troubleshooting requires technical knowledge, patience, and logical thinking. The process usually involves checking power supply, testing components, and verifying circuit operations step by step. Troubleshooting is important because it reduces downtime, improves equipment reliability, and saves repair costs. Skilled troubleshooting helps maintain efficient performance in industrial and consumer electronic systems. 20. Why do you want to work in the electronics field? I want to work in the electronics field because I am passionate about technology, problem solving, and innovation. Electronics plays a major role in modern life, including communication, automation, healthcare, and computing systems. I enjoy learning about circuits, electronic devices, and how systems operate efficiently. This field also offers opportunities for continuous learning and career growth because technology constantly evolves. I am interested in contributing my technical skills to improve system performance and develop reliable solutions. Working in electronics allows me to combine practical knowledge with creativity while building a successful professional career.